Alright, so we've got Lecture 3, Unit 8, and we're going to look at the strength of acids and bases. One of the biggest things I want you to get out of this is going to be the fact that your ionization and your dissociation, those two words, they literally mean the exact same thing when we're talking about chemistry. And when we say that, we mean the separation of a compound into ions. Alright, so the separation of a compound into ions. Now, so far we studied one-way reactions where we've had things like reactants. Reactants go to products. Right? We got one arrow, it goes from your left side to your right side. But the thing is, with this, when we're talking about acids and bases, this is going to be used mostly for showing things that are very strong. Okay? So these reactions completely dissociate, and so therefore very strong acids or bases. Okay, now one of those ideas of an acid base being strong, one thing that we need to look at is what makes it strong. When we say strong, that's like what gives an acid its strength? Okay, so the H plus ion, right? And we call that, another name for that is a, yep, no, there is concentration of this, right? True. But an H plus ion is also called a proton. There we go. Perfect. Right? H plus ions are protons. Now I gave you the idea of protons being like what? What was the analogy I used? Go ahead. No. Things that do what? They burrow in. You could say they're either like, yeah, okay, there we go. You remember, they're either like insects or like piranhas. Okay, now why are they like piranhas? Because they attack, right? So these H plus, think of them as like little attack dogs, little piranhas. If it's an H plus, it attacks. It goes crazy. It just absolutely goes insane, right? And it tries to attack everything. And so the more H plus ions you have, the stronger your acid is going to be. And if we have a base, what are we looking for? Instead of an H plus, it's an OH minus, right? Same type of deal. That's just going to be for our base. And so those OH minuses are going to run around and try to attack whatever substance you have inside your acid or base. Okay? So here's an example. Again, we've got HCl, H2O going into H3O plus. I'm going to circle that. Plus Cl minus. Okay, now this hydronium ion, I want you to think of it as being equal to an H plus ion. Okay, because hydronium is just, this H plus is hanging out on the water for a little bit, and it's still going to be just as lethal, still going to be just as deadly as an H plus ion. So if I say, you know how we've done things where we do calculations for an H plus ion? If there's only hydronium, like you notice right here, if I said, hey, find the strength of the acid, and I didn't say that there's an H plus, use your H3O plus, because these are going to be equal. When I say H plus, it just means H3O plus. Same type of deal. Okay? So, to kind of sum this up, if we have HCl, it's a really strong acid. So that means that 100% of the acid HCl dissociates or ionizes, right? Those are the same. So that means it's a strong acid. So just to kind of recap this for a second, if we have our H plus and our Cl minus, right, on our product side, and on our reactant side we had HCl. Remember, we start here and we go to this, right, reactants to products. When we go from HCl to H plus and Cl minus, every single HCl molecule is going to turn into an H plus and a Cl minus. Right? So all of them are going to split right down the middle to open this up. This guy is going to be our attack dog. The more attack dogs we have, the more piranhas, the stronger the acid is going to be. Because we're going to look at this next one, the weak acids, and not all of the weak acids are going to convert to the H plus. Okay, so let's take a look. We got weak acids and bases. Now these reactions can also be in equilibrium, where they can go both directions. Remember, we had some of them have the arrows, like it goes this side and this side. It's going to be the same type of idea, right? Reactants and products. Hold up for just a minute and we're almost done. One example is going to be acetic acid. It's going to be added to your H2O to create your acetate ion, and H3O plus, right? This is going to be our acid. But because this acetic acid compound is so stable, it's not going to really need to give off that H so often, right? And so what it's going to want to do, and I'm going to go ahead and just skip down to this picture real quick. This is perfect because you see, with a strong acid, again, underline strong acid right there. With your strong acid, you start off with HA. HA is just kind of your, the A stands for a placeholder for like your Cl, or for anything else that goes next to the A, right? Your HCl or your HA is going to turn into H plus plus A minus. Right now, this is just your conjugate base. Okay. You have your HA completely goes to H plus and A minus. Check out how much H plus there is. That's a lot of H plus, right? Now what gives your acid power? How much H plus it has. So this is a really strong acid because it has a lot of H plus. Now your weak acid, you start off again with the same amount of HA, and then instead of completely dissociating, like you notice, how much HA is left on this side for the strong acid? Is there any HA left? None. There's none left, right? So it completely dissociates. Whereas for HA, on the weak acid, there's still some left, right? It doesn't completely dissociate. That way, look at how much H plus we have. Not that much, right? Why? Because this is usually a lot more stable, or in equilibrium. You could think of it like that. Equilibrium. Okay? So the thing I want you to write down over here for the first and second reaction. Okay, for the first reaction, completely dissociates. Right? Completely dissociates. And so that means it's a strong acid. And for the second reaction, it only partially dissociates. So that means it is a weak acid. Perfect. Any questions? No. Awesome. Well, I will see you guys on Friday. Have a great day.